students. Well, yesterday I was asked a few questions about molecular drawings. Well, I'm here to answer those questions. I helped a few kids out yesterday that didn't really understand what I was saying in the video. What? So I'm going to give you some hints, and these are very, very helpful hints. And it really comes down to those valence electrons again in the outer shell in that octet rule. So on your homework, actually I want to give you a little cheat sheet first. On that cheat sheet, I want you to write down a few notes, and this is going to be your cheat sheet. First, we're going to talk about the elements that are on your homework. We have hydrogen, which is an H. That's its element symbol. It's a really bad H. But anyways, hydrogen, it only has one electron in its outer shell. We know that because it's in the first column. So therefore, hydrogen can have up to 2 electrons, make it stable. So therefore, it only can make one bond with another atom. And one of the other atoms that we're looking at is oxygen. Yes, that all-important oxygen that we need to breathe. It has 6 electrons in its outer shell, and in order to fill that octet rule, we need to put 8 electrons in its outer shell. So it has 2 more electrons to go. Therefore, it can make 2 bonds with other atoms. But oxygen, remember, there's also a thing called double bonds and triple bonds. Oxygen is a gas that usually comes bonded to itself in 2 atoms of oxygen, or it's called O2. And since these oxygens need to fill that octet rule, you have 2 bonds between those oxygens. So that is an example of a double bond. All right, we also have in our homework carbon atoms that we're working with. Carbon atoms are in second column after the transition metals, so it has 4 electrons in its outer shell. So therefore, it needs 4 more electrons to fill its outer shell. Therefore, it can make 4 bonds. You should write this down. And then there's one more element that we're working with, and that's nitrogen. And it has 5 electrons in its outer shell because it's in that third column after the transition metals. Therefore, it needs 3 more electrons so it can make 3 bonds. All right, so go back to those examples that I talked about the other day. You remember hydrogen peroxide? Well, that's H2O2. That means it has 2 hydrogens and 2 oxygens. Think of those 2 hydrogens, 2 oxygens as our puzzle pieces to make this molecule. So we know we have 2 hydrogens, so we're going to draw 2 hydrogens somewhere down below. And this is how you're going to do this on the homework. Now I'm going to put one over here, and it goes H2, so that we know. I usually work with the left and right, so we know we're going to use a hydrogen first in the molecule. That's kind of how it gives you a clue. So those hydrogens can only make 1 bond. So we're going to put 1 bond coming off of each one of those. And the oxygens can make 2 bonds. So therefore the oxygens are going to have bond with each one of those atoms of hydrogen. And they can make 1 more bond, so therefore they're going to bond with each other. And this is our molecular drawing for hydrogen peroxide, the example that I showed you the other day that helps, we use it for cuts and some other stuff. And then we had methane. Yep, the cow fart one. That's my favorite one because we get to talk about cows and farting in school. But anyway, the chemical formula for that is CH4. That means it has 1 carbon and 4 hydrogen atoms. So we're going to put the carbon first. It's first in the formula. That's how I usually get my clue. And we know that it has 4 bonds coming off of it because of our little handy dandy notes that I gave you up here. 4 bonds. And what do you think we're going to attach to each one of those bonds? A hydrogen, because they can make 1 bond with that carbon, filling the octet rule for that carbon. So now it has 8 electrons around it and it's stable. And those hydrogens all have a bond with the carbon. And remember, hydrogen needs 2 to make it stable in its outer shell. Doesn't really have an octet rule because it's small, one of the smallest atoms. And that's our molecule for methane. Remember, this one's an H up here, so I'm going to circle that. And our next molecule that we talked about was hydrogen cyanide, HCN. That was the poison. That's the one that'll kill you again. HCN. So that means we have one hydrogen, one carbon, and one nitrogen. So we're going to start with our hydrogen because that's our first on the left. And we know that has one bond, so we're going to have one bond coming off of it. And we put a carbon in the middle, and that needs 4 bonds. And we have nitrogen, which we know carbon already has 1 bond, so we know that it needs 3 more bonds to connect to it. And nitrogen needs 3 bonds, so we're going to put a nitrogen over here and make 3 bonds. That's a triple bond. That's the biggest amount of bonds you can put between 2 atoms. And that gives nitrogen 8 electrons, carbon 8 electrons around it to make it stable, and then hydrogen 2 to make it stable because it's the smallest atom. And that's a few clues on how to do these drawings. Just remember that hydrogen has 1 bond, oxygen has 2 bonds. I kind of put these out of order, but carbon has 4 bonds and nitrogen has 3 bonds. Think of these as puzzle pieces that fit in with each other. I'm going to do one more example. CO2. Let's do carbon dioxide. It's a byproduct of a lot of chemical reactions. And we're going to put our carbon first. This is an interesting one because it has 2 double bonds. Because oxygen needs 2 bonds, so it has 2 double bonds. And then carbon needs 4 bonds, so it's going to have 2 double bonds between 2 oxygens. One of the examples that I gave you is vinegar. It's a very difficult one. Contact me, email me, message me to help you with that if you need it. I think you guys can do it now that you know how many bonds to stick to each one of these atoms. Also, there is a picture of me that's going to be floating around the interwebs pretty soon, somewhere in an email. And I actually posted it on my Google Classroom this morning. The first person who responds saying where they found the picture of me, and I put the picture up on my Google Classroom so you can see it, so you know what they'll be looking for. But if you can find that picture somewhere next week, you're the first to email me and tell me where you found that picture. I will send you a little gift in the mail. During this pandemic, I can't get handed out in the classroom, so I'm going to send you a little thing in the mail if you find that picture, just for fun. And apparently, we talked a little bit about Zoom etiquette yesterday. Another thing that you shouldn't be doing, I'm not going to name the student who did this, but screenshotting people without them knowing it. That's not cool. It was all in fun, but sometimes people can be mean or do something weird. And that student sent me the picture because they thought it was funny. It was funny to me, but don't do that. And those are my helpful hints for drawing these molecular drawings. Have a good day. I really like apples.